need you to get out the green sheet or the blue sheet, whatever color you had for your notes. We're going to finish the back, especially when inscribed angles. We're going to get that done today. And then you have an in-class assignment that you should have picked up when you walked in. You're going to need to know the definition of inscribed angles. Remember what the relationship is for central angles and the corollaries to inscribed angles to problem solve to finish the in-class assignment. I need you to copy down the definition, highlight, or have two different colors to color code the relationships. For an inscribed angle, the vertex needs to be on the circle, okay? And the chords are the sides of the angles. So an example of your inscribed angle, we could say angle 1, or you can name it angle ACB. C is that vertex that is on the circle. Now, there's a relationship with the angle, an inscribed angle, and the intercepted arc. Your intercepted arc is the arc that lies between or inside the angle. Between the chords or inside the angle is the relationship. So, the intercepted arc for your inscribed angle would be which arc? It's the arc in the interior of the angle. Yeah, it'll be this arc, AB. Okay? Yeah. So you have to know or identify two things. You have to identify the inscribed angle, and you have to identify its intercepted arc. Those are the two things, key things for today's activity. So the intercepted arc would be AB, but you would put the curve over it to show it's that part of the circle. Now, the intercepted arc will always be the arc that lies inside the intercepted angle. So it's always going to be inside the angle. Yeah. And I said intercepted side. Inside the inscribed angle. Now, here's the rule. The rule is, first identify if it's an inscribed angle. If you see an inscribed angle, so whatever you see, and I'll put this in red so you know it's a rule. Whenever you have an inscribed angle, its measure is half the intercepted arc. The measure of the angle will be half the arc, and vice versa. Okay? So I could double the intercepted arc. Double the angle, sorry. And I'm going to abbreviate this so I have room. And it would equal the intercepted arc. Okay? All right, so everything we do from this relationship is going to apply this rule and do that to justify. Now, you can have an inscribed angle as long as the vertex, so that is your vertex right there. Because it's still on the circle, you could have an inscribed angle or inscribed angle relationship with a chord and a tangent. So the intercepted arc that they wanted you to see here would be that X. That curve is still inside the angle. So as long as the curve, the arc is inside the angle, it's going to be half. The angle is going to be half that measure. Okay? So, two ways we can see them. The first relationship we're going to look at, the corollary to that relationship, is whenever you have more than one intercepted arc. inscribed angle with the same intercepted arc. So I'm going to start with angle 3. Here's angle 3, like such. Okay. What is the intercepted arc with angle 3? Intercepted arc. Yeah, B. What was that? Yeah, DE. Okay, so intercepted arc is the DE. All right. Now, if I'm looking at angle 4, what is intercepted arc? DE. Okay, so if they intercept the same arc, okay, if the angles intercept the same arc, they are going to be congruent. So angle 3 and angle 4 would be congruent because they intercept the same arc. Y'all see that? Okay, so angle 3 is congruent to angle 4 because they have the same intercepted arc. This angle 4, DE is the intercepted arc. And then if I look at angle 3, it's the same intercepted arc.
So would that make those two arcs parallel?
Would it make them parallel?
Yes.
If I knew that the distance between them, I don't know. I know that arc is. I still would need to know the distance between them is the same. Okay. So now look at angle 1. Okay, angle 1. What is the intercepted arc with angle 1? GF. All right. So highlighting GF. That's the intercepted arc. Does any other angle have that intercepted arc? Yeah, angle 2 has the same intercepted arc. So what do I know about angle 1 and 2? Yeah, they're going to be congruent. So angle 1 is going to be congruent to angle 2 because they have the same intercepted arc. Which was GF. Okay. Okay. So if they have the same intercepted arc, the angles are going to be congruent. All right, so that's the same relationship. That's the correlate to the inscribed angle theorem. Now, same type of thing. We're going to use what we know about inscribed angles. If I look at angle 1, right here, the intercepted arc to angle 1 is what? The bottom half of the circle, right? So what is the measure of this bottom half of the circle? 180. It's a half circle, so it's 180. I know it's a half circle because M is the center, and I have a diameter there, okay? So if the intercepted arc is 180, and the inscribed angle is angle 1, what would be the measure of angle 1? 90 degrees, because it's half the intercepted arc. So if you have an inscribed angle in a circle, and the intercepted arc is a semicircle, half a circle, then it is a right angle always. Okay? So if we have an intercepted arc that is a semicircle, then the inscribed angle is going to be a right angle. 90 degrees. All right, now, so you can see the relationship that happens here. Do you see that the quadrilateral is inside the circle? All right, I want you to start with angle S because it's inscribed, because that S is on the circle. The vertex is on the circle. What arc corresponds with angle S? What's the intercepted arc for angle S? Yeah, so okay, T to R. All right, remember we can use that rule, that relationship, we can go forward or backwards. So now I have the angle, so what must be the measure of the arc TR? 200, and you double it. because the angle's half the arc. All right, now, if I know that TR, that arc is 200, then the remaining arc would be 160. Yes, because the whole circle is 360. That makes sense. All right. So, yep, that makes Q80. Because angle Q intercepts the arc TSR. Do y'all see that angle Q goes with the 160? Yeah, divide 160 by half, and then we get the 80. All right, so now I want you to look at Q and S. Okay? What's the relationship do you think is between Q and S? First, look at their location. How are they related to each other? They're opposite. Okay. And then together, their sum is supplementary because they have a sum of 180. So here's the rule. If a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. That always happens. So that means they equal 180. And that means, yes, angle R would be 85. Nope, it's not that hard. I'm hoping. It shouldn't be. We're good on that? Okay. So opposite angles in a quadrilateral are going to equal 180. All right, so we're going to look at some guided practice here. Oops. All right, so you can do this on a sheet of paper, scratch paper. I'm not going to pick this up, or you can do it mentally or just use your calculator. I just want to see, can you follow the relationship? Okay, so the first thing I've given you, or we need to make sure you still recall and use, is a central angle. Central angle. That's when the vertex is in the center, okay? On the center, excuse me. Vertex is on the center. All right, so I've given you an example of central angle. Central angle, that makes sense, yes? What about this next one? Why isn't it coming on? Okay, why is it not a central angle? Not on the center, all right. So, you're going to see some central angles today. Central angle theorem states that the measure of the intercepted arc will be the same as the central angle. It's not the same. It's not what we just did. So if I know the angle is 110, the intercepted arc is 110. If I know the intercepted arc is 110, the angle is 110, vice versa. That's for central, on the center. Okay? So, with that being said, you can do it mentally. I want the values of x, y, z in this example in the corner. X, Y, and Z. X we should get real quick. What is X? 25. Z is 55. How do we get to the Y? Add the 2 minus 180. 100. Okay. So central angle, intercept arc are the same. Now, we just got finished talking about inscribed angle. Where's the vertex for an inscribed angle? B is a vertex, but where is the vertex for any inscribed angle? On the circle, okay? It's on the circle. So, yes or no, is that inscribed? No, that is not, okay? Yes. How are those not chords? Do you still have a chord that exists within that same secant? Okay. All right, what about here? What type of angle is this? Yeah, that's the central, okay? Yes, okay, so you know when it's inscribed and when it's not. So, vertex on the circle, the sides of the angle are chords. So we know that the intercepted arc is in the interior of the angle, lies between or inside the angle, and we should understand the measure is going to be half the intercepted arc. So if I give you the arc, you should give me the angle. If I give you the angle, you should give me the arc. So 55 is half the 110. That would work with a tangent and a chord as well. So let's do these mentally. Y'all see? It's inscribed. So the arc would be, yeah, 140. You double the angle. All right. Yes, you have the arc. All right, so we got it. So try this one. Okay. EFH is who we're trying to find. Yep, there's the intercept the arc, the 130. Take half of that, we get 65. Does that make sense? You got to be able to find the inscribed, if it's an inscribed angle, and you have to be able to find its intercepted arc. Angle G is the red angle I've highlighted for you. We want the intercepted arc, GF. It's greater than 100. Grayson didn't even use a calculator. Okay, the angle is 58 using linear pair or using supplementary. These two angles here are adjacent and they're on the tangent, which is a straight line, so they have to equal 180. So if angle G is 58 and if you double it, then the intercepted arc is 116. Are we okay on that? All right. So we remember that if we have two inscribed angles that intercept the same arc, what do we know about those two angles? They're congruent. Now, that could happen to more than two. Would they all be incongruent? Yes, because they all intercept the same arc. Okay? And then remember that half the semicircle will make the right angle always, so you have a right triangle. Okay? And then what do we know about inscribed quadrilaterals? Yeah, opposite angles are supplementary or 180. So, mentally, we should be able to do this. Okay. Z is 100, yes. Y is 60. Are we okay on that? All right, don't forget this, guys. All right, so. Oh, I'm gonna start. All right, this is the worksheet you picked up. Put your name on it. This is the in-class assignment that we are going to do using our notes, using what we just learned. All right, the first one you're going to find is angle ABC. I'm hoping you see that it is an inscribed angle because B, the vertex, is on the circle. No, so close. What do you need to solve this? We need the intercepted arc.
Oh snap, it's 55.
Yeah. Yeah. That arc is 110. Using that a circle is 360. So yes, 55. All right, where could you start with number 2 based on what's given?
X.
Yeah.
X160.
X is 160 because it goes with the 80. You double it, we see 160. I'm going to go label it on the circle as well. Let me do better job of that. All right, now, what else do we know?
C and Y.
Z and Y are congruent. How do we know they're going to be congruent? Because the chords are congruent that contain them, okay? If the chords are congruent, then the intercepted arcs containing in that chord, yes, both 100. Yeah, it's not a race, okay? I mean, you got a big race to the top for yourself, but not in class right now. All right. All right. So let's look at number 3. What do you see? What do you know? Should be a corollary that we see automatic. I'm hoping. Anything you know. Who's 90? Yeah. We should have 90 right here. Because this is the center. We have a diameter. So this would be half a circle. So do y'all see? Every time we have basically a triangle with the side or with the hypotenuse being the diameter, the angle is going to be 90. It's going to be a right triangle. Now, so what do I know remaining? No, I don't know they're equal. Yes, together they equal 90 because a triangle equals 180, but it's a right triangle, so the remaining two are always going to be acute angles that equal 90. All right, are going to be complementary. So we said 2x plus 1 plus 2x minus 3 equals 90. 23. Yeah. We should have 4x minus 2. So 4x equals 92. So x equals 23. And the value of x, yeah. Which are congruent? 1 and 2, you're saying they're congruent. Why are they congruent? Okay,
Oh,
let's,
they have that same.
yeah, they do have the same intercepted arc. So if I look at angle 1, it intercepted arc is right here. But that is also the same arc for angle 2. All right, so I need to get that arc. No, not 90 degrees. I don't know that's the diameter. 180. Y'all see here, these tick marks, these chords? This 150, or 105, excuse me, goes with that chord, right? So wouldn't this be 105 as well? Yeah, the arc is 75. This arc is 75. So that's my answer. Yeah, they're both 37.5. Oops. You take 75 and divide by 2. All right, you have these two. I'm hoping real quick, real simple. You should see, let's see if you see the relationship. Use your notes if you need to. All right, hopefully we saw this. X, 96, Y, 107. Opposite angles are going to be supplementary, equal 180. All right, and hopefully you see X, Y, and Z all equal 90. They all inscribe a semicircle, okay? Or intercept a semicircle. All right, let's go to number 7 and 8. 8 we should do, hopefully just mentally. Let's think about where we could start on number 7. There's more than one way to start this problem. Start with Y? Okay, good. We could start with the isosceles triangle. So you said the 180 minus the 54 divided by 2. So 63, yeah. So I get 63 and 63. All right? So we know Y 63. Where could I move from there? What? I can use the 54 and its intercepted arc. Yeah, 108. There we go. All right, so if that's 108, then Z would be 54. We got Y is 63. How do I get to that X? You can do it two ways. You can use, let me do that differently. You can use the intercepted arc, but you have to get to the arc. Or there's another way. Yeah, you could use this arc, or what do we know about this line? It equals 180. So that means all three of them together equal 180. So x would also be what? 63. Okay. X will also be 63. All right, we know we can do 8 mentally, right? We should know these automatic now. X is 75 because it's opposite the 105, and Y is 94, opposite the 86. All right, now let's talk about where we could start with number 9. 4x equals. Okay, we could do that. What is 4x going to equal? That's the question. Okay, I heard 152 and I have 76. Yeah, okay, so you're right. It's the 152. Because if I use this angle, the intercepted arc would be double that. So it's 152. And 4x is a central angle. So 4x is going to equal to 152. Because 4x is in the center. So x is going to be 38. All right, how do we get to that? The y. Y is not the same thing. The 3y should equal 76 because they intercept the same arc, right? So that means they're going to be congruent. So the 3y is equal to 76. This is a decimal answer. Yeah, 25.3. Okay. All right, on 10, they want us to find x and y. Okay, so x, if I look, I'm looking at angle L. Yes, because they intercept the same arc. Y'all see that? So L and P are congruent. They intercept the arc MN. So angle L is congruent to angle P. So then I know that 5x plus 9 is equal to 6x. So we should see x really simple. Yeah, x is 9. So now let's look at the expressions with the y. Like look at n and m. What do we know about n and m? How do I know they're equal to each other? They both intercept the same arc. So angle m is congruent to angle n. Yeah. Yes, y equals 3. All right, I'm going to get you started on these last two because they require you to do multi-steps and using all the relationships. Now, always label what they give you. They're telling you that the measure of arc QR equals the measure of arc ST, and those measures are 50. So QR is over here. I'm outside between Q and R. I'm going to put 50, and it is congruent to ST. It is also 50. And they tell us that RT is the diameter. So it cuts the circle into 2 semicircles. So what else do we know? Just go with, before the angles, get this circle on the outside labeled first. Okay, arc, I'll start there. Let me do that. Guys, if they start with arcs and they tell you the diameters, you need to use your arcs. You need to find all your arcs, if possible. Because it's the diameter, RT is 180. If I know that that's 50, then you should know that Q, whatever T, is 130, and we know RS is 130. I didn't hear that. I'm sorry, Javon. Okay. All right, so now that we have all our arcs and we have all the exterior, the curves of the circle labeled, now we can get to our angles. So, what would be the measure of angle 1? No. 50, because it's a central angle. Angle 1 is in the center. It's not inscribed. So it's the same. It equals its intercepted arc. It's the same measure. So we have 50. All right, what about angle 2? Yes, automatically. Intercepted a semicircle. What about angle 3? Huh? 25. It's half the intercepted arc. By angle 4, 65. Half the intercepted arc. Y'all see the 130? Okay. Angle 5. I hear two different answers. First of all, I need to know is what's the intercepted arc, and I'm gonna do it a different color. Angle 5 is the tangent and the chord. Yes. Angle 5 is 90, half the 180. And then angle 6. Think about this. Yep, 25. Aren't these radii? So wouldn't you have an isosceles triangle there? Okay. So if this was 50, this was 130. Then we had 25 and 25. All right. So the last one is yours. Okay. Same type of thing. Make sure you know, you label the relationship that's given, and then see if you can find the remaining arcs. Because they give you FE to be 78, and then they tell us that BD is perpendicular to BF. So right there is 90 degrees. The intercepted arc is the D to F. What would be 180? This side over here is 180. They're both 180, but you need to find this angle, this arc. Okay. This 90 degrees has the intercepted arc DEF. What is not a smaller number? Yes. Just see you have a diameter, BE, because it cuts the circle in half. Here's a half right here. Here's the other half. Huh? Try it. So we have 39 half to 78. All right, then they ask for the measure of the angle FBC. So that is the angle over here. That went with the intercepted arc of 102. So angle FBC should be what? 51. Then they want the measure of arc BD. BD. In order to get the measure of arc BD, I needed to find DE. What is the measure of arc DE? Yeah, 102. Because this, and I put it in yellow, right here was 180. So 180 minus 78 will give this remaining arc 102. Okay, so I'm going to go ahead and write 102 over here. Oops. 102. All right, so if that's 102, then the remaining arc would have to be 78. So I'm going to go ahead and label that 78. Then they want the measure of ABD. 39, half to 78. Then FB, the arc FB. 102. And then the angle DBE.
Teachers, students, please practice the rush if you,
51.
Reminder, teachers' lunch will be offered lunches A through D, whichever
All right.
lunch you have. Please make your way to the library for the appreciation.